Hello everybody, this is Lars, your developer and consultant from PTV, and in today's Rock and Code session I want to show you how to code with PTV Developer a fancy auto-completion with single field address search. So let's dive into the code, and before I start I want to give you an impression how the result will look like. So let's just jump into the application. So I already prepared a vector map, and I have some kind of fancy frame in a dark mode. And what we are going to do today is building an input box where we can input an address string. And on the fly, we geocode this address, and we also look at the result quality, and we will create a star rating scheme. So let's start it. What I have here is, as usual, an API key. And as you see today, we have TSX file extension. So today we are coding in TypeScript, and you see that it is as easy as using JavaScript. And what I already prepared is the frame. And today we're gonna look into that search component. And therefore we need an API key. And I already prepared an interface where we hand in the setter for marker positions and also the variable for marker positions. And that you see here. So in TypeScript, you usually have to annotate with types. And now let's start to code the main logic. So what we need is a return function that contains all the elements we're gonna render. And so here we have return. Then we just use wrapping division for our content, and now we want to code the text field. So let's use a division, and let's also use a padding. And today we are using Tailwind. It's a nice utility-based library for building your CSS, and you just have to state class names to have certain functionality, like hover functionality, or like just coding a simple padding. And what we want to have here is we want to use a padding, and we just annotate it with p-1, and then we have a nice padding without having to bother with the CSS code. And now additionally, we start with the input element. So let's use a standard HTML input box. And we hand in some parameter, so that I'm not gonna type out. So I just copy it and then explain to you what all the things are doing. So it's just some long agglomeration of names. So you have a flexbox, you have a row orientation, you have some paddings on the x-axis, you have some paddings on the y-axis. You have a background right, you have a border width of 2, you have a border color of right, you have rounded edges so that you can just configure it rounded. And if you have MD, it's just medium size. You also can have a small radius. And here we also have the focus outline. And we have, when we hover over it and we have the focus, we have a border color of blue. And that's all what is done by this class name. So now we have a fancy input box. And what we will need, we want to react to typing in the input box, and that's why you need an onChange event listener. So let's just state it. We have onChange event, and we just take the event that is coming from our standard box, and we're gonna call the input change function and just hand over the event. Now, yeah, for sure we do not have it because we have to code it. And so let's just add it. We have const input changed. And we have an event, and in TypeScript, you need the type. It's a change event, a basic HTML change event, and we just type it. It's HTML. and it's an input element. And now we just close our type annotation, and then we have the lambda function and come to our functional body. And here we want to store that search text in a hook. So we additionally gonna use some use state hooks to maintain our state over the rendering cycles. So we have a const and we use destructing. So we have search text. And we also have the usual setter function for set search text. And now initially, let's just set it, initialize the use state hook, and it's going to be a string because we are typing addresses. And let's initialize it with just an empty string. And we are done with the search text. And now we can just add this to our input change function. So let's set the search text. So set search text, and the event dot target dot value attribute just stores the contained text. And then what we're gonna do, we do not want to do a geocoding when you only input one single character. So we set some kind of minimum length of 5 keystrokes so that we just start geocoding when we have a few amount of letters. So then let's just ask if event target.value, so that's the string. And if the length is bigger than 5, then let's do the geocoding. So what we do is we want to show a candidate list. So it is not clear that you have unit geocoding if you have not enough letters or your postal code does not really fit to your city. Then you have a candidate list, and we want to show all the candidates or maybe just a selection of the candidates. And then we give the duty to the user to select the candidate that is the best one and that meets the inputted string. So that's why we use here a if statement to look for the length of our input, and then we want to set the candidate visible to true, so that will be again a use state hook. And then we want to geocode. So there we have auto-completion sometimes plays tricks with me. Geocode. Okay, let's first write that function and then it will be automatically detected. So let's just write it first and make our life easier. So const geocode. And as in the last episodes, we usually work with asynchronous functions, so we do not block our graphical user interface, so everything is still maintainable and handleable. So let's take as an input the address that is of type string, and then let's just code out our body. And there I just copy that URL from PTV Developer, so you find it in the documentation. So we have a classical fetch, we have the endpoint geocoding, and we want to geocode addresses, and we use that geocoding by text. We have that search text that we just hand in that address. So we have here some kind of typo in the country filter. You can also restrict. So we want to geocode in Germany, then we set the country filter already to Germany. That makes it a little bit easier for the search engine. And yeah, you do not have to search the whole world by default if you know we were only operating in Germany. So that's what this URL is telling us. It's a basic get method. So just state it here and just insert your API key. And then we just react to the completion of that fetch event, and we just transfer our result into a JSON type so that we can easily use it and read it out. And then we use the set candidates function to set our candidates, and we want to restrict the candidate selection just to 5 candidates. We do not want to show more candidates if there would be more. So that's why we just use here a slice operation to shorten the array. And now here we have the set candidates, and the set candidates is also a use state hook. So let's code it out. And so const candidates, that's the variable, and the setting function is candidates. And we just use here to make our life easy in any type. If you use it in production, you could write a type for it to be on the safe side. Here we just say it's an array and it is any type. So that is our statement here. And then we just initialize it with an empty array, and then we have it. And what we also need is candidates visible. So that will be just a Boolean variable. So const candidates visible. And as usual, set candidates visible. So here auto completion helps us. And it's a use state. And what we want to use here is a variable of type Boolean, and we initialize it. We initialize it with a false value because we do not want to start with an empty selection. And so we have candidates visible here. And that's the main call to the PTV Developer API. So we do here the geocoding, and each time we call this input change function, we trigger this by a keystroke. Then we set the search text, we compare if we have a length that is bigger than 5, and then we do the geocoding. And now we are able to call it here geocode. Now it is automatically detected, and we hand in the address string. Or no, we hand in the event.target.value. And then we are fine. So far to the geocoding method, we have the input changed, and then we can come to the star rating. So if we have a geocoding score, the score is always between 0 and 100. If we have a full score, we want to have 5 stars in our candidate display. So therefore we need some kind of functionality to render 5 stars. So let's just copy that calculate star function, and let's go through it step by step. So what we will hand over is the rating between 0 and 100, and we calculate the number of full stars. So 100% corresponds to 5 full stars. And yeah, if you just subtract the number of full stars from 5, you have the number of empty stars. And then we just want to show in a flex element the stars, and therefore we just map over an array of the filled stars and fill it up with empty stars if the score is not 100%. And then we additionally just need that get filled star SVG to print out the scalable vector graphics of that stars, and that I also just copy. because it's not a functionality, it's just some kind of rendering stuff. Um, that was the wrong one. So what I wanted to have is these two functions. So you see here get fill star, and it's a scalable vector graphic, and it's just some path that depicts a star, and it has a special color, and it is filled if you have a filled star, and if you have an empty star, you just have the surroundings of that star, and that's all what these functions, two functions, are doing. So now we have that stars, and now we do not have any errors anymore at the calculate stars function. And now we can go on with the markup of the candidates. So the candidates will be shown beneath the input box. So let's just copy it. And as you see here, what we are using just an unordered list, and this unordered list again has some tailwind styling. And the nice thing here is that you can use string interpolation, and you can have also access to variables. And here we use the candidates visible attribute, and if the candidates should not be visible, then we hide them. Otherwise, we do not use that attribute hidden. And we have some kind of pagination and some margin to the top, and again, some white background, some rounded corners, and some shadow. And then we access our candidates variable, and we just map over it, and we inject some list item, and yeah, to make it unique, we just use a key. And then we also have an on-click handler. That means if you click on that candidate, you want to select it and to only show that selection. And therefore, we need a select handler that gets as a parameter the candidate. And again, we have some basic styling for this list item. So again, paddings and text and some hover styling. And then we show the formatted address. So we also clean the address with PTV Developer. If you have some typos in the street name, they are corrected, and then you usually show the formatted match from the database. And then we just depict the return of our calculate star function, and there we have just 5 stars, and we have a certain number of filled stars and a certain number of empty stars. And that's all what this section is doing. And now let's go to the select handler. So that's not that much of a code. So let's just use it here, just above our calculate stars function, and you see the select handler. And again, we hand in candidates, and then you just call the set search text function, and you set the name to the formatted address to correct it, and then you set the candidates visible to true, to false, because you have done the selection, and then you are basically done. Okay, let's see if I just have forgotten some little styling or some braces. Set search text, set search text. Text, do I have a typo? Set search text. Zip. No. Export search. So basically, we have the functionality. So I guess I have somehow messed up with some kind of braces. So let me just copy the finished code. And now we do not have any errors. Again, let's change that filter to DE, and let's remove that. And as you see, we have all that functionality and we have that structure. And now let's save it and let's look at the result. Okay, no errors. And now let's look here to the result. And you see here that input box with the rounded edges. And if we just click inside, you see that very small blue border that is automatically created when you click inside and when you set the focus to that input box. And then let's geocode Karlsruhe, and you see how that candidates just pop up. You have that hover effect of black that is done by Tailwind automatically. Now you would have a match of 100% because you have 5 filled stars. And if we now add a street, for example, Heid and Neue Straße, we get some already some candidates, and now we would have a 5-star rating if we have the address in the right format, and if we would have some kind of slight error, or if we remove that, let's just reload it so that I can show that effect. So if you would, for example, Karlsruhe, Heid und Neustraße, then you would see you have here the typo, and if you select the candidate, then you have selected the cleaned address, and even you have the full name of street. And that is how that geocoding works. And usually our customer use that when dispatchers get some kind of phone calls with ad hoc orders, if you get via another system, just an urgent order before dispatching, and then you want just to type it into a text field and get some suggestions to have a very fast geocoding. And so far to today's session. Stay tuned. Do not forget to subscribe the channel, and I'm looking forward to see you in the next Rock and Code session. Bye.